Okay, next problem I'm going to go over here is number 9. The body surface area, BSA, of a human being is used to determine some doses of medication. The formula for finding BSA is BSA equals the square root of H times M divided by 3,600, where H is the height in centimeters and M is the mass in kilograms. A doctor calculates a particular dose of medicine for a patient. What must the mass of the person be for the dose to be appropriate if BSA is less than 1.9 and height is equal to 160 centimeters? Well, let's go ahead and see what we can do here. So I'll go ahead and tell you there's not enough room right here. I'm going to do this one off to the side. And so what I'm going to identify right now is it gives me this whole equation, BSA equals H and M. So I need three variables, BSA, H, and M. And I see BSA right here, and it tells me BSA is less than 1.9. So there's one. And then another variable is this height one right here, which will go with the H right there. So it also does tell me that it's asking for what must the mass be. So that also tells me I'm solving for M. So I can go ahead and substitute information into this equation over here. And so what I will do is exactly that. I'll say I have 1.9 is less than. So notice right here, my little alligator, my inequality is eating the 1.9. So I'm going to keep it doing the same thing over here. So we've got 1.9 right there, and then we've got our square root of H times M, where H is 160. We do not know what M is, and we're dividing by 3,600. So I've got my equation right over here. So all I need to do is to go ahead and rearrange and solve for M. Notice my radical on the right is all by itself. So since it is by itself, I can go ahead and square both sides. And that gives me 1.9 squared, which 1.9 squared is 3.61. So I get 3.61 is greater than 160 M over 3,600. Okay, go ahead and get that. And now I would go ahead and to get M by itself, I'm going to go ahead and multiply both sides by 3,600. Keep in mind, just right here at this step, you honestly could get M by itself by multiplying by the reciprocal of the fraction that you have right here. 160 over 3,600, you could multiply by 3,600 over 160. Get it done in one step, or you can take two. I feel like most people will probably take two. They'll probably see that. So when I do 3,600 times 3.61, that gets me 1,290, or not 1,000, 12,996. And that's going to be greater than 160 times M. So then to get M by itself, I'm going to divide by 160 to both sides. All right. And so now that I've divided that, that gets me 81.225 is greater than M. So let's make sure that we can interpret what this says into context of the question. So it says right here, what must the mass of the person be for the dose to be appropriate if BSA is less than 1.9 and height is equal to 160 centimeters? Well, we already solved it for our BSA to be less than 1.9 with a height of 160 centimeters. That's what this was right here. And so this is the mass of the person with that information. And what this is saying is that the mass has to be less than 81.225. So that is the answer to our question. The answer is the mass must be less than 81.225 kilograms. That's what we have right there. Now, just like with the last two ones, what I'm going to do as well is I'm going to go ahead and solve this equation right here for M before substituting anything in for anybody who wants to try it that way. First, I'm going to say let B equal BSA because I don't want to sit here and write BSA each time. So I've got B is equal to the square root of H times M over 3,600. So just like what we did over here to get it by itself, our first step was to square both sides. So that gets me B squared is equal to H times M over 3,600. Okay, now I would go ahead and multiply by 3,600 to both sides. Gets rid of that here, so that gets me 3,600 times B squared is equal to H times M. And then my last step would be to go ahead and divide both sides by H. So I have M is equal to 3,600 times B squared, all divided by H. And again, I could just substitute values in right there into the calculator right at the very last step. And so in other words, if I was to do that, I would go, okay, so I got 3,600 times B, which we had identified B was the 1.9. So I'd have this 1.9 squared. And then we would divide that. Oh, I don't know why I was changing colors. Then we would divide that by H, which was 160. And so when we would take that and put that into our calculator, let's do that. So at that point in time, we'd have 3,600 times B squared, so 1.9 squared. Oops, I'm sorry, I did my parentheses the wrong way. Change. Okay. 1.9 squared divided by 160. And it gets us 81.225. And sure enough, isn't that exactly what we got right here? It is. So, like I said, you can do either way, whatever works for your brain. Neither one is wrong. Okay. All right, let's look at number 16. A town council approved the relocation of a police station so that officers can reach the courthouse more quickly. The courthouse is located at 3-2 on a coordinate grid. The new police station will be built on the vertical line x equals -1 to ensure that the two facilities are exactly 10 miles apart. Find the possible y values of the police station's location. So in other words, what we're looking at here is we have on, that did not work. Man, I just jumped all over. What we're looking at right here is a grid. If we were to go ahead and draw this here, we'd be at 3-2 right here is what they are saying is the courthouse. And then the police station is at x equals -1. It's somewhere on this vertical line that we have right here. And so it's saying that it needs to be from the courthouse to the police station. What it needs to be is it needs to be a distance of 10. Well, this isn't working. I need to go from here to here. There we go. It needs to be a distance of 10. So wherever along this line is, that would get me 10. So I can see right now I've got two possible directions. I can go up, I can go down. So I'm going to have two possible locations where this could be. And I've just got to figure out exactly where that is. I'm trying to find the distance from one point to another. Distance, guys. Distance formula. Think back in your brain, back to Algebra 1 when you learned that. I'll go ahead and refresh your mind. It's D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. You're finding the difference in your horizontal change squared plus the difference in your vertical change squared, and then you square root it. You're doing Pythagorean theorem of your triangle. But this is what we've got right here. So like, if I just use this visual that I have right here that I've just drawn, hypothetically speaking, we have this courthouse here at the location of 3-2, and we have a distance of 10 miles. And so this other hypothetical location of the police station needs to be somewhere at location, we know -1 because it's at x equals -1, but we don't know what y is. Notice, this is everything I need to use my distance formula. Distance is 10. I've got 2 coordinates for x and 2 coordinates for y. I just have one of them as a variable still. So let's go ahead, label this information, and substitute this in. I'm going to go ahead and label this one x1, y1, and x2, y2. You can label either one either way, but personally what I'm looking at is I'm looking at the variable that I have right here. I want the variable in front. I didn't want the variable at the end. I didn't want to be going 2 minus y. I'd rather have y minus 2. It just looks more appealing. It looks more common to what you're used to seeing. But you can get through it either way. It doesn't matter. All right, so if I go ahead and substitute this into my equation, that gets me 10 is equal to the square root of, and then x2 minus x1, so that's -1 minus 3 squared, plus y2 minus y1, so y minus 2 squared. Okay, so now I've got everything. I'm just solving right here for this y variable. So again, in order to solve for y, I've got to get everything away from it. So now I'm going to look, my radical is by itself over here on the right. And since it's by itself, there's nothing on the outside added or subtracted or multiplied or divided. Then I can go ahead and square this side and square this side to get rid of it. So that gets me 100 is equal to, and let's go ahead and combine some like terms here. -1 minus 3 is -4. Okay, -4 squared. So that gets me 16. Okay, plus, and then I have this y minus 2 squared. Okay, so that gets me that. Now I can go ahead and, again, to get y by itself, I've got to get everything away from this squared term. So I'm going to subtract 16 from both sides. So when I do that, that gets me 84 is equal to y minus 2 squared. You might be tempted to go ahead and expand this and do y minus 2 times y minus 2 and FOIL it out. Don't. Save yourself the headache. Recognize that I have something squared over here and it's equal to something. I can use my square root method that we learned back in polynomials. I can square root both sides to undo that squared. Okay? Now, again, keep in mind, if I'm undoing a square, by taking a square root to both sides, I have a plus or minus square root 84. And that's how I'm going to get those 2 possible answers. Remember, I said we're going to have one going up and one going down. Well, that's how that's going to happen right there. And so then that gets me this is equal to y minus 2. At this point, I would encourage you to go ahead and reduce your radical. That is something that we know how to do. The largest perfect square that evenly divides out of 84 is going to be 4. So that simplifies down to 4 and 21. So if I do the square root of 84, it's the square root of 4 and the square root of 21. So that 4 is 2 square root 21. So this is plus or minus 2 square root 21 is equal to y minus 2. So again, in order to get my final answer here, I just add 2 to both sides. And so that's going to get me y is equal to 2 plus or minus 2 square root 21. And that's the y coordinate of where the police station could be located. I apologize, it's a really weird number, but sometimes they can be weird numbers. Sometimes they can be a pretty whole number that just looks nice. They won't always be that way though, but this would be the y coordinate. If it asked for the possible coordinate point, then the coordinate point would be -1, 2 plus or minus 2 root 21. And that's how you would write that. Alternatively, I could take this entire equation, my distance formula, and I could also go ahead and solve that for my y1. So I have x2 minus x1 squared plus y2 minus y1 squared. I could go ahead and do this. It would be a little bit rough, but I could. So I could go ahead and square both sides. So I get d squared is equal to x2 minus x1 squared plus y2 minus y1 squared. Well, I'm about to run out of time on my recording. And then I'm going to go ahead and have to subtract this whole entire term. So I get d squared minus x2 minus x1 squared. And that gets us equal to y2 minus y1 squared. Again, I would square root over here on the right to get rid of the squared term. And so then that would get me square root of d squared minus x2 minus x1 squared. And then now that this is all by itself, then I would just add y1 to both sides. So